We go for a site visit, walk around the property, look at places that they suggest. We tell them ahead of time what we're looking for in terms of openness and things. And then we get a site lease agreement in place with Penn State and in this case, a school. And we come out and install concrete pads. You can see 2 concrete pads here. This is 4x4 that holds the rain gauge and wind screen. And then we have a 2x2, it's about 2 foot into the ground as well. And we dig the holes, we form them up with 2x6s. We call in a concrete truck for delivery, pour them, and then we have to let it cure for at least a couple weeks. There's 3 bolts that are into the concrete. We have a jig base that we put into the concrete in the hole, and then pour concrete around it. Well, we have temperature and humidity here. This is just a sensor that goes up into the shield. This is a pie plate shield, we call them, and it helps to keep the sensor accurate, keeps the sun off of it, obviously keeps the rain off of it. And inside here, there's 2 sensors on here. There's one sensor that's a temperature sensor, and there's another sensor that's a relative humidity sensor. Temperature sensor is nothing more than something that changes resistance as the temperature changes, and so we can measure that resistance change. Relative humidity is similar. It changes capacitance as the humidity changes, so we can measure that capacitance. We have a solar radiation sensor, measures the solar radiation. Over here we have a wind speed and direction. It's a propeller vane anemometer. So the wind blows, obviously this keeps it oriented into the wind, and we measure, it's like a pot in there that as it swings around, it changes the value that we measure with the data logger. And so we can get measurements for every 1 degree of wind direction. And then the faster this spins, it makes a pulse. We count those pulses, and it's calibrated to X pulses for Y wind speed. So we just measure that and make the conversion. And here we have snow depth. It is a sonic sensor, and it emits a pulse of sound, non-audible, and it bounces it off the surface, whatever it is. And we will put this white board underneath it. It's a snowboard, and that'll be mounted directly underneath it. And what that does is it gives it a nice clean surface to bounce off of. Otherwise it'll be hitting, grass, and things will grow up and you'll get false measurements. And it measures the time between when it emits the pulse and when it receives a signal back. And from that time you can calculate a distance, and then you can get your snow depth. Well, the big antenna is not an antenna. That's more like a lightning rod. That just helps keep the system grounded and protects from lightning strikes. Although it's really hard, a direct strike or a really close strike, there's no preventing it. So do our best. And we also have an environmental camera up there that's pointed typically westerly in some fashion, and that gives us pictures every 2 minutes, and those are transmitted along with the data. We transmit data every 1 minute. We measure every about 10 seconds, average those 10-second samples to a 1 minute average, and transmit that back for analysis. We have soil temperature and moisture over here. I just dug this hole today. We installed conduit for that one as well. And so I dug down about, it's 50 centimeters is our lowest measurement, so about 22 inches. And we installed sensors at 50 centimeters deep, at 30, 20, and 10 centimeters. And that gives us a good profile of temperature and moisture. Moisture is useful for doing predictions of things like flood and flood forecasting. We have to install this windscreen. This windscreen basically keeps the air flowing more horizontal over the actual tipping bucket funnel. That's good because if you don't have this windscreen, the wind will come and create a high pressure over the bucket, and that'll help ruin your measurements a little bit. So this just helps. So come out and have to install these pipe flanges, drilling 4 holes in the concrete. Have to put the base for the pipe that's holding the rain gauge, drill holes for that thing, put the anchors in, tighten them up, and then mount the pole. And then, I don't know if you want to look inside here, this is the tipping bucket itself. This is just a funnel. So the rain falls in here, drips out the funnel and into an actual bucket that tips back and forth. So when it fills up, it gets heavier and tips over. And there's a magnet that goes by another magnet and it creates a little pulse, and that little pulse is counted by our data logger. So this just has a little debris screen, because you can see the hole is pretty small in there. There's actually seeds that fall in there and are just the right size, so once they get moisture in them, they swell up and they completely clog the thing, so this helps a lot. And then when we're installing the concrete bases, we have to install conduit that we run under the ground. Here you can see the grass is kind of still dead from that. And so we just run the wire through there, come out to the data logger and run the wire into the data logger. We have a fairly large solar panel, and we just have that wired into our battery. And inside here you can take a look. So the solar power comes in to this is our charge controller. Charge controller basically controls everything. It says, okay, I've got solar, I'll put it into the battery. And when it doesn't have solar, then it controls the battery flow out to the data logger and the camera and anything else that needs power. This is our modem. It's a Campbell Scientific modem that's on the Verizon network. And so we just have real-time communications with the sites through that.